Hi scientists, today we are going to talk about volume. When we hear the word volume, lots of times we think about when we listen to the TV or when we talk in class about keeping our voices low or yelling, or the TV volume is down or it's really loud. Today we're going to be talking about a different kind of volume. We're going to be talking about how much space something takes up. That's the measurement of volume. And it's something that scientists look at all the time. Are you ready to look at that with me? I have 3 containers right here. All 3 containers are different sizes. Now, it looks like this container has more water in it. I colored the water different colors so you could see it. But it looks like this container has more water in it. This one looks like it has the least amount of water in it. But guess what? All 3 containers have the same amount of water. This right here is 1 cup of water. And this is how much water is in all 3 of these containers. I poured the exact same amount in. Each of the containers is a different size. Some are taller than each other, some are narrower or skinnier, and that determines what the water level looks like when it's inside the container. I have a cup right here. This glass, I'm going to pour this cup of water, the exact same amount that's in these 3, into this cup right here. And let's see, when I compare this one with those 3 right there, it looks like there's more in this cup. Just like it looked like there was more in this glass too. All 3 of them look like they have different amounts, but it's all the same amount of water. It was 1 cup of water. It just looks different in the different containers. When you play around with water, maybe in the bathtub or in the sink, you can ask mom or dad and say, hey, could I have a measuring cup and measure water into different cups and see what it looks like? Because this right here is a measuring cup and it tells me on the side of the cup how much water I have. And I used this to pour the water into all of those different containers. Now, sometimes volume looks different. Right here, I have a glass that has 100 kernels of popcorn in it. 100 popcorn kernels. Whoops, one fell. Doesn't look like a lot, does it? Now I'm going to show you what happened when I popped 100 popcorn kernels. Look at the difference. I wonder why 100 unpopped popcorn kernels only take up this tiny bit of volume in this glass. But when I popped 100 of those same kernels, look, it's overflowing. I had to really make sure and put them in carefully so that they wouldn't overflow. So when I popped them, they take up more room. 1 tiny little kernel takes up a lot more space when it gets popped because it's bigger. So it takes up more space. I wonder if there's anything else that when air is added, or if something gets bigger, but it's the same material, takes up more space. Can you think of something that you might have at a birthday party that might be hanging up? Or you might get one when you go to a carnival or to a park. Sometimes you see people who have them. Balloons. It's the same thing with balloons. If I dump out this popcorn right here, I'm going to dump that out over there, and I put 1, 2, 3, 4 balloons into this cup, that's how much room it takes up in the cup. Those 4 balloons take up that much space. I'm going to pour this popcorn out now too. Do you think I could get 4 balloons blown up into this cup? Let's see. Look what happens. I can't even get one balloon into the cup. Now this is still a balloon. It hasn't changed. It's just now filled with air. Just like the popcorn was also changed when I popped it. So some things take up different amounts of space when they change. The water, I changed the color, but I didn't change the amount. Water, no matter what, 1 cup of water is the same. But 1 cup of popcorn, if it's unpopped or popped, or balloons, isn't always the same. Now, I also have some beans right here, an entire cup of red beans, 1 cup of red beans. This is a measuring cup that you use to measure things that aren't liquid. I used my measuring cup here. This one is used for measuring liquid. I'm going to pour this into this glass right here. And this is a cup of beans. Now guess what? I have a cup of gummy bears. Let's see how much space a cup of gummy bears takes up. It was almost about the same. That's very interesting. Now, there is more space in between all those gummy bears, and there's air, so it might not be exactly the same. Let's now see what 1 cup of popcorn looks like. Are you ready? I'm going to pour a cup. Here's my cup of popcorn. Those look the same too. Now I wonder why a cup of something looks the same in both of these glasses. What's different about those 2 glasses than when I did the liquid? Can you guess? These glasses are exactly the same. They're exactly the same size. So 1 cup of something is going to look exactly the same in those 2 glasses. Just like in the water didn't look the same because the cups weren't similar. Let's see, here is my cup. I'm gonna pour the kernels back in there. I'm gonna pour my beans out. Let's see, I'm gonna take this blue. Now remember, it was 1 cup of water. And I'm going to take this one, it's kind of an orange color, and it's 1 cup of water. It's about the same. This one looks like it has a little bit more. I think it's only because all of it, I can't get out of that jar. We'll see what happens if I can get all the green out. There we go. So look, these 2 right here, which did not look the same when we had the water in there, it's exactly the same when you have the water in the same size glass. So 1 cup looks the same when it's in the same size container. But when we move containers and use smaller containers and larger containers, it doesn't always look the same. Maybe you could go play in the sink, ask mom and dad first, or in the bathtub with some measuring cups and see what else can hold a cup of water. Bye, scientists. Have a good day.